Hi guys, it is Mr. Dave with the RayKitty Creation Workshop, and you are watching the RayKitty Science Project. Thanks for checking us out again today. We've got some fun science. Today, just about everything is pretty safe for the big guys to the little guys. So this one's a pretty safe one to do. So if you want to gather some materials, we're going to be working on electroplating, okay? Yes, it's just as fun as it sounds. Now, when we're doing it today, it's going to be a little bit kind of the cheap and easy version, okay? And it's also going to be a lot faster than if you were to do this at home. If you were to do it where you wanted a nice clean result at home. If you want to do it like this is a little bit more dynamic for the students, so you'll have a little bit more fun with this because you can show it off. It happens very fast this way. So what we're going to use for our electroplating, if you watch some of our previous episodes, in one of them we kind of did a very quick overview with a 9-volt battery and some coins, and in that one we used hydrochloric acid, which is not safe for the kiddos, but we used hydrochloric acid and we used salt. Okay, now this one here is all ingredients and things that you probably have at home. More than likely you have all of these at home. So we're not going to be using the hydrochloric acid, so you don't have to worry about that. The dangers, or not really dangers, but things to kind of watch for in this one here is you are going to have a battery. So you want to make sure that when we're making this circuit here, that our battery doesn't short circuit for very long. Okay, and that just means we don't end up making a loop. You'll know if you have that loop because your battery will. I like to use what one of my students last week said when we were doing one like this. They're like, my battery's getting hot and it smells funny. So if your battery gets hot and it smells funny, you probably have a short circuit. Okay, now it's not going to be immediately dangerous, freak out, leave the room, anything like that, but you will want to unhook it. There's a very, very slim chance if it stays short-circuited too long that little kind of cardboard part on the back can pop, but it's a very, very slim chance. It will get hot, but you know, there's really no hard danger level there. That's just something to be careful about. So this one here, if you want to grab your materials, these are all things that if you're building that RayKitty science kit at home, you'll probably have. These are things we've used in experiments before. We have these alligator clips. Okay, these are very inexpensive. You can buy them at some of your chain stores. Again, I'm not like not sponsored or anything, but Harbor Freight, you can get a big bag for hardly anything. Okay, so this is a good one to get at Harbor Freight or online or anywhere like that. Now these here, we're going to be using 2 of these clips. Okay, now we have a positive and a negative, so we're going to note that with our red being our positive and our black being our negative. Okay, so you'll need alligator clips. To make it a little bit easier, you won't need one of these, but it is kind of handy to have. And again, you can pick this up at just about anywhere in the little hardware section. This is just a clip for our 9-volt battery, okay? And it just makes it a little bit easier. If you don't have one of these, you can clip these alligator clips directly to the battery. It's just when you're moving them around, sometimes they'll pop off. So this is a very inexpensive little gadget that will help this go a lot easier. Okay. The other things that we're going to use is salt. Okay, plain salt. So this is boring salt, not that like Himalayan beautiful salt that has the extra dirt and stuff in it. This is just regular old plain salt. Okay, so you'll use salt. You can use that fancy Himalayan salt. Let's just use plain salt. Salt, and this one is kind of hard to get. This is water. Yeah, no, it's just water. Yeah, it's easy to get. You go to the tap, you open it up, we get water. We are very lucky here to be able to do that. So water, salt, a 9-volt battery, some alligator clips, and that is the majority of this experiment. Now, you're going to need what you're going to be electroplating and where you're going to be stealing those ions from. Okay, now, stealing the ions, yes, we're actually taking some of the molecules off of one of our material and depositing it onto the other. Okay, so we have what we call an anode and a cathode. Okay, now again, I had a student with, with a nice little way of, this is a catch-ode, right? Because it's going to catch everything. So we have an anode. Our anode is going to be on our negative side. Okay, so your anode is the negative, your cathode is the positive. Okay, now when you have a negative, this is one if you want to get a little bit into with into the math end or the STEM end of things. When you have a negative, okay, this is big math. If you have 4 minus 3, you're taking away 3, right? So the negative is taking away. When we look at our battery here, the negative of our battery is taking the electrons away. Okay, so with our anode, the part that we hook to our negative, we're actually going to be taking the ions away from that material. Okay, now I have here something a little bit different, and I have this pretty blue solution here, and we'll be using this one in just a little bit. I'll show you this solution, but this one is a solution that I made. It took a couple days to make this solution, but I'll tell you how to make that solution in a little bit. And this is actually called copper 2, 2 copper 3. And so this one is going to be fun in that electroplating, but it's not necessary. So I'll show you how to do that one in a little bit, because we're going to start with regular salt and water. Now remember, our black is going to be our anode. Okay, our black is our negative or our anode. Okay, our anode is going to be giving the material. Our cathode is going to be receiving the material. Okay, now we're going to be using pennies and nickels. Now these pennies and these nickels look pretty gross. The ones that I have here, these are pretty gross. Now that's kind of for a reason. Okay, these gross ones here are actually going to allow that reaction to happen a little bit faster because we already have some of that verdigris, that patina on there of that copper, how that copper starts to change color and turn that little green color. If you watch one of our earlier videos, we talked about cleaning that up and that showing up. That green color is actually copper that's already been deposited on the surface of even the rest of the copper. Okay, so that's copper 3. If you have some dirty coins, okay, it's going to work faster. Now, by dirty, I mean with that patina on there. If they are just greasy from people's hands and mouths and pockets in the street, then you're going to want to wash those off. Soap and water works fine. You'll want to wash them off if they're that kind of just dull brown color. You'll want to wash those off. If you want to go even crazier, you can hit them with a little bit of sandpaper. Okay, so these are the coins that we're going to be using. Now, first, we're going to use our pennies as our anode. Okay, the penny is going to be giving off some of its material. Okay, so our anode, we're going to take our 9-volt battery, and I'm going to put my little clippy on there. These clippies are also nice if you're working, with students because you can kind of show that the black is going to be the negative and the red is going to be the positive. Okay. Now in electricity and electronics, that's not always the case, but it is usually the case. Okay. So we have our positive and our negative, our cathode and our anode. Now on this, when I clip this on, this is very important. When I clip it on, I'm going to want to make sure that I clip that onto that conductive part of our little clip there. Okay, if I clip it onto this insulator here, we're going to get a whole lot of nada. So we want to clip it onto that connective part or that conductive part there, that little metal part. Okay, so we have this one connected. Now I'm going to clip up my other little clip. Same thing, my clip is going to go right onto the conductive part of my wire here. Okay, that is the biggest oopsie or mistake that you can make, and that's the most common. This is an experiment I've been doing all week long in a whole bunch of different classes, and that is usually the case. If nothing happens, check that first. Okay, so our anode and our cathode are set up here. We're going to start with our electrolyte solution. Now, if you watched last week's, we did put on or show different measurements of different electrolyte solutions like Gatorade and things like that. Our salt is going to be the electrolyte in this solution. So I'm going to put the salt right here in my water, okay? Now I have salt water. Yep, there you go, regular old salt water. So I'm stirring it up. The electrolyte solution is going to allow those charged ions to kind of ride on the back of this mineral, the mineral being salt, okay? So our saltwater solution is very important. Now, the stoichiometry, meaning the ratios, isn't super important. Did you see I just dumped some salt in there? I got salt in the water. This is a super saturated solution because there's too much material in there. And so if we were to heat it, but you don't have to even worry about any of that. So here we go. I have my penny. I have a dirty old penny, okay? And I'm going to put my clip on this penny. Now, if you do want to kind of take this one a little bit further and experiment a little bit deeper into it, I'll show you that as we go, and I'll get into it a little bit. But we have our nickel here, okay? So I have my nickel, and my nickel is going to go on the cathode or positive side, okay? And as we can see right now, this nickel's fairly clean, right? It's not too bad. But my penny, that's pretty nasty, okay? So I got a pretty nasty little penny there, but my nickel's not too bad, okay? And that's really about how you would like it for this one here. Now I'm going to move this out of the way, and we're going to put our solution here so you can see it, okay? Now our whole little device is already set up here. This is an electroplating device. It's already made, it's ready to go, okay? So what you're going to do is you are going to take these little anode and cathode, okay? I'm gonna switch them around so I remember. Anode and cathode, okay? Anode is our negative, cathode is our positive. Now when we're watching this, what we're gonna do is when you put it into that solution, you're going to see something happen. If you look in at the negative side, you can actually see that thing bubbling up, okay? And you can see a little bit of vapor. We've got an awesome cameraman there, thank you. He's really showing it perfectly. But you can actually see those little bubbles traveling from our anode to our cathode, okay? And so we're going to leave this sitting here for just a minute while I'm explaining what's going on, okay? Now, on this here, our solution is allowing that electricity to pass through it because it's an electrolyte solution, okay? And we can see that solution start to get a yicky color there, okay? We're getting kind of a green-yellow color in our solution. That is actually those ions that are being ripped and stole from that penny, okay? So we're losing those ions from the penny or from our anode, and they're actually being deposited on the cathode, okay? So we're taking them from that penny and they are going to that nickel, okay? So we can see we've got a nice strong solution. We've got a nice powerful battery. Now remember how I said that this is the fast, dramatic way of doing things, okay? Now that means that this one here, those big bubbles and things like that, that's because 9 volts is pretty high voltage for doing this. If you wanted to make some pretty stuff like jewelry and things like that, you can really make some beautifully electroplated material, but you'd want to do a lower voltage, like a AA battery or a C battery, something like that. But the 9 volt, when you're doing the experiment with the kids and kiddos, you guys are doing this one, it's way more dramatic and way more fun, okay? Because this has only been in here for just very little amount of time, but I'm going to pull these things out and you're already going to be able to see what's happening here, okay? When I take these out, you can see that our nickel has already received some of that copper from that penny, okay? Now it's not just dipped on there, it's actually a part of it. Those ions have actually bonded to our nickel here. Now this gray color, if we give it a few minutes, will start to turn green, just like the patina on copper. So this gray would begin to turn a greenish color, okay? So what we're going to do next is, if you want to kind of conduct this as an experiment, if you wanted to do it for a science fair project, something like that, right now we have half of the nickel that was not affected, and we have half of the nickel that was affected. Okay? So what we're going to do is we're going to change that nickel into quadrants. Okay? So when we dip it now, this corner of the nickel will be unaffected. This part will be dipped in the second material, this part in both materials, and this part in the first one. So you can have 4 different quadrants for an experiment. Now, if we can look into this yicky water here, we can see how nasty that water looks. Yeah, it is pretty gross. Now, that gross is actually those ions, okay? So we're going to do it again. We're going to dip them in again with that angle. You can see immediately that well, one of the students called it fizzling. And we debated whether fizzling is a real word or if it's a scientifical term. But you can see around that penny there that liquid is beginning to turn greenish color, right? We're getting a nice green. And that is that copper patina, okay? And that is copper 2 to copper 3, okay? So we're going to let this fizz for just a second, or fizzle for just a second. And we're going to pull this out. Notice this was not in as long, but we can see that we already have that big deposit there. Now, the reason we have that big deposit is because now our material has a lot more of those ions in there. Remember how at first that material hardly had any of those ions on there, but now it didn't have any, it just had the salt water, but now we have all those ions floating around in there, okay? So now we have these 4 different quadrants. So what we're going to do now to kind of mix things up, now that our solution has the ions in there already, we're going to turn our nickel back like it was the first time. Okay, so we're turning our nickel back to the first one. You're going to leave your penny the same, except you're going to switch your anode and your cathode. So now our penny is going to be our cathode, and our nickel is going to be our anode. Now, you would think that, okay, well, then it's just going to steal them all and take them to the penny, right? But now we have to take into account, we now have all of these ions that are already in our material, okay? So when we dip these in, we're going to watch that fizzling effect, okay? So now we notice that the fizzling is happening on that nickel side rather than on the penny side, okay? So we've got a nice little fizz or bubbles happening on that nickel side, and we're not getting anything on the penny side. The bubbles that you're seeing is very important because those bubbles are hydrogen bubbles, okay? Now, hydrogen is flammable, okay? If you watch our next episode, you'll see we will be generating hydrogen and doing some work with that. But we want to just kind of point out that those bubbles are hydrogen bubbles for now. Now, you can see our nickel here has a different rate because instead of just a little bitty really fast fizzing, we're getting kind of a slower, big bubbles that are forming on there, okay? Now, when I pull this out, you're really going to notice the difference on my nickel and on my penny now, okay? When you look at this nickel now, you can see that on that nickel, we have that pretty copper color, right? Now, that copper color isn't just painted on there, it's part of that nickel. It has now been absorbed and taken into that nickel. That metal has bonded, and so our nickel now has a copper finish, okay? We can even take just a little bit of this paper towel, and I'm not going to wipe real hard. Now, the reason I'm not going to wipe real hard is because we've done this so quickly, we don't have a super strong bond, okay? But when I wipe this off, you can see now that our nickel very much has some beautiful copper on there, okay? Now, a nickel is actually plated with two different materials, one of them being, well, nickel. Okay? It's the only United States coin that is named after the material that it's plated with. Now, the entire thing is not nickel. It's actually electroplated, just like we're doing here. But it's a combination of nickel and copper. Okay? But we can see here that our penny is now very plain Jane, right? We've dissolved a lot of the fidelity, a lot of the image off of that penny. And we've actually deposited that over here on this nickel, okay? So, in doing it this way, this is a great way to kind of show a big dramatic change there, but that when they're actually electroplating things, if it's chroming something on your car or making jewelry, they will usually use a solution that already has the material in it, okay? And I'll put this on the white so you can see it a little better there. So this pretty blue right here, that's actually penny water, okay? It's actually vinegar, okay? So you take a cup of vinegar, take some salt, put some salt in the vinegar. These pennies here, these nice beautiful pennies I have here, you can see how much they have been oxidized and reoxidized. That green color that's forming on here is actually what is making this solution blue. So this is copper 2 solution, and you can make this copper 2 solution with a cup of vinegar, a little bit of salt, throw in a handful of pennies, okay? At first, those pennies are gonna look beautiful, nice and shiny. Take them out, they're gonna look like this. Put them back in, take back out, put them back in, take them back out. And after you do that, leave them out for a while, let them dry. This one took me an evening and a morning to make this solution here. But this solution already has a whole lot of those copper ions, okay? And you can see how much purer those copper ions are in this rather than in our eau water, okay? Eau water is a scientific term, but in our eau water. So what we're going to do now is we're going to get one of our cleaner nickels, okay? And we are going to use it as our cathode, okay? Remember, the cathode is the positive, okay? And the positive is the one that is going to be receiving the ions. It's on the positive side. So when you think of electricity, it's the same as this here. When you have a negative, you're taking away the electrons because it's negative. When you have a positive, you're adding them. So our anode is actually gaining the ions from this, okay? So we're going to put these ones in here. I put my nickel on that one. I need my penny. Give my penny back. Okay. So we're going to put these ones in this other solution, and we're going to see kind of the difference. Now, if you're doing this at home and you want to make a nice, beautiful electroplated whatever it is, whether it's jewelry or whatever, you can do this with different materials. You can do this with brass. You can do this with a paper clip. You can do it with gold. And you can plate other materials. Now, before you take, Dad's fancy chain and throw it in the vinegar water, make sure that you get some permission for that one. So, what we're going to do is we're going to put our anode and our cathode into our new solution here, and we're going to see how quickly that nickel changes. Okay, so we're going to put them into our new solution. You see that bubbling happening right away onto our penny side. Okay. Now remember, this is a pretty high voltage for this particular one. I can actually see that happening already. Okay, so we already have a good transfer of those ions. But when you have a solution that already has the material in it, okay, then you can make a nice clean version. And again, this is a 9 volt, so it's going to be a little quicker and dirtier version. But we're going to pull this out. You can see the difference that happened on our nickel, and look at the difference that happened on our penny. We have a huge difference that is happening because of those ions that are in our copper 2 solution. Now this is already starting to turn that nice green color. If you're doing this one at home and you leave these ones out for a little while, you leave them out overnight, that half of this nickel will be a beautiful, beautiful patina green color. you can see what's going on here. So to make this solution, salt and vinegar, throw in a bunch of pennies, take them out and let them dry. And then once they dry, they'll start to get ugly, yucky looking like this. Okay. Now, we don't really have time in a half-hour episode to kind of show the whole process, but these ones, like I said, I did for a good long while. Now, what you will want to watch out for is some of my pennies, the inside of a penny. If you watched one of our previous episodes where we dissolved the inside of a penny is actually zinc. And when you're doing this, because you're stealing those copper ions, some of your pennies, the outside of the penny will actually begin to peel off. So you want to kind of keep an eye on your pennies. You'll have these gross pennies. You're going to put them right in that material. Okay. You're going to let them set. They're going to get cleaner looking, and then you'll take them out, let them get dirty looking, back and forth, back and forth. That will make you a beautiful copper 3. If you put a lid on it, it will last a long, long time. So you can see how dirty, yucky that penny was, and just from being in there for a couple seconds, we cleaned it up pretty good here. That process is fun if you want to do a nice clean electroplate, but if you want to just make it more dramatic, okay, for the sense of the experiment itself, you'll want to do it with just salt and water. Okay, so this is electroplating. We have our anode, which is our negative, and our electrode, which is our positive, and we are transferring ions from one material to another through an electrolyte solution. Okay, all right, well, thank you for watching. Again, I am Mr. Dave with the RayKitty Creation Workshop, and you are watching the RayKitty Science Project. Thank you very much, and don't forget, science shows you matter.